Good morning, everyone. Today, we're diving into a numerical method called fixed point iteration. It's a way to approximate solutions to equations, especially when we can't solve them directly. So think of it like this. Imagine you're trying to find the perfect spot to stand in a room where your reflection in a mirror lines up perfectly with you. So that's kind of what we're doing with fixed point iteration. First, let's define what a fixed point actually is. So a number p is a fixed point of a function g if g of p is equals to p. So in simpler terms, when you plug p into the function g, you get p back. Graphically, a fixed point is where the graph of y is equals to g of x intersects the line y is equals to x. So why this is the case? At the intersection point, the y value of g of x is the same as the x value, which means g of x is equals to x. Why do we care about fixed points? Because they often help us find the roots or solutions of equations. So the problem we're trying to solve is often finding the root of an equation. F of x is equals to 0. We can algebraically rearrange f of x is equals to 0 into an equivalent fixed point problem x is equals to g of x. Now let's look at an example. Suppose we want to find the root of the equation f of x is equals to x cubed plus 4x squared minus 10 is equals to 0. We can rewrite this equation as x is equals to square root of 10 minus x cubed divided by 4. So in this case, g of x is equals to square root of 10 minus x cubed divided by 4. Now let's pick a starting guess. Say x0 is equals to 1.5. We'll plug into our g of x function to get our next approximation. So x of 1 is equals to g of x0 is equals to g of 1.5 is equals to square root of 10 minus 1.5 cubed divided by 4, and it is equals to 1.3484. So we repeat this process. Now we plug x1 into g of x to get x2. So x2 is equals to g of x1 is equals to g 1.3484, and now it's equals to 1.3751. We keep plugging each new approximation back into g of x. So if the sequence of x values converges or gets closer and closer to a value p, then p is the fixed point and the root of the original equation. So the process we just did is called the iterative method. So it's a successive approximation method. So the formula is simple. X key plus 1 is equals to g of x key. So we start with an initial guess x0 and generate the sequence of approximations using this formula. So the goal is that the sequence x key converges to a value p, then p is the fixed point and the root of the original equation. So here's a summary of the algorithm. So first, start with an initial approximation x0. Then, calculate x key plus 1 is equals to g of x key. Then, repeat until the error x key plus 1 minus x key is less than a specified tolerance. So the tolerance is a small number that determines how accurate we want our approximation to be. So the smaller the tolerance, the more iterations we need, but the more accurate our result will be. So what are some potential issues with the fixed point iterations? It is not every choice of g of x will lead to a convergent sequence. So choosing a good g of x is crucial for the success of this method. So in summary, fixed point iteration is a powerful tool for approximating solutions to equations. It involves rewriting the equation in the form x is equals to g of x and iteratively applying the function g until we reach the desired level of accuracy.
Convergence condition. The fixed point theorem. The iteration will converge if certain conditions are met in a given interval a and b. 1. G of x is continuous on a and b. 2. G of x in a and b for all x in a and b. 3. The most important condition, the function g of x is not too steep near the fixed point. There must exist a constant k less than 1 such that absolute value of g prime of x less than equal to k less than 1 for all x in a and b. The choice of g of x matters. Rewriting f of x equals to 0 as x equals g of x is usually not unique, and only one form may satisfy the convergence criteria.
Graphical interpretation. The iterative process is a cobweb or staircase diagram drawn between the graphs of y is equal to x and y is equal to gx. Convergence types. Monotonic convergence or staircase. 0 less than g prime p less than 1. The approximation approach the fixed point directly. Oscillating convergence, spiral or cobweb. -1 less than g prime p less than 0. The approximations alternate side of the fixed point but get closer. Divergence types. Absolute g prime p is greater than 1. The approximations move away from the fixed point. So let's proceed to the example problem. The given problem here is find the root of function of x is equal to x cubed plus 4x squared minus 10 is equal to 0. In near x sub 0 is equal to 1.5. So, ang good iteration na ay absolute g prime x less than 1. So, diin dito nakuha ng x is equal to square root of 10 minus x cubed minus 4. So, ang gibuhat ana kay ang 4x squared kay gi-transpose, then over 4 and gi-square root para mabilin ang x. So, ang gx na to kay square root of 10 minus x cubed over 4. So, since na naman tayo function, i-iterate na nato. Ang button na to kay ang gx. I-substitute nato ang given nga x sub 0 sa gx. So, mo na makuha ang 1.28869. And mo na natong x1. So, sa x sub 2, ang button na sa ninyo kay g is equal to gx sub 1 para makuha ang 1.40254. So, ipadayon na kagya pa nga process hangtod maabot mo sa root nga p is equal to 136,523. Mao na siya ang good iteration. So, sa bad iteration is ang gibuhat niya ang x cube ang iyahang gi-transpose. So, mo na iyang function nga x cube is equal to 10 minus 4x squared. Then, ang iyahang pag-transpose, so nahimo siya ang x is equal to 10 minus 4x squared raised to 1/3. So, using this gx would cause the iteration to diverge. So, magmatter siya sa imong pag-transpose sa imong function.
Advantages of fixed point iteration. Simple algorithm and easy to implement. Low computational cost per iteration can be used as a basis for more powerful methods like Newton's method. Disadvantages: convergence is not guaranteed. It depends entirely on the choice of g of x and the starting guess x sub 0. 2. Linear convergence. It can be slow, especially when dealing with dollars or money. Lastly, it can only find one root at a time. Summary and conclusion. Fixed point iteration is a straightforward and powerful numerical method for approximating roots by repeated applying of function g of x. Remember, the selection of iterative function g of x is crucial for ensuring convergence, which is determined by the condition absolute value of g prime of x less than 1. Once again, good afternoon and thank you for listening, everyone. God bless.